All right, so let's go ahead and work out this integral. So we have a polynomial of degree 2 on top and a polynomial of degree 4 on the bottom. So it's a proper fraction. No need to do long division. So let's go ahead and factor the denominator. You have the integral of x squared over x to the fourth minus 1 can be factored into x squared minus 1 times x squared plus 1 dx. Now, we can factor this further. So this is equal to, let's go ahead and write it here. We have x squared over x plus 1, x minus 1, and x squared plus 1. Of course, that's not factorable further, so leave it right there. Now let's write out the partial fraction. So this is equal to the integral of, so you have a linear factors. So I can write this as sum a over x plus 1 plus b over x minus 1 plus, now here, this is a quadratic, so you have cx plus d over x squared plus 1. And we're integrating this piece. So now we need to figure out what is a, b, and c, d. Then we can integrate the rest. If you're confused how we got to the setup, I have a video on how to decompose rational functions. You can watch that. I'll leave the link in the description box below. So let's dive into how to solve for these coefficients a, b, c, and d. So multiply both sides of this equation by the LCD, which would be this denominator right here. So if I do that on the left side, we have just x squared, but on the right side, you have a times this denominator and this denominator. So that's x minus 1 times x squared plus 1 plus, now b, when you multiply by the LCD, you'll cancel the x minus 1 from the bottom, and you'll have b times x plus 1 times x squared plus 1 plus cx plus d, and that's going to cancel the denominator x squared plus 1. You will have x plus 1 and x minus 1. So that's the equation we have to solve to figure out a, b, and c. So that's our goal, is to find what is a, what is b, c, and d. So we're going to use the substitution method where you plug in some values for x, convenient ones, so that way the other constants are 0. For instance, if I choose, let's say x equal 1, I get the following. This will go to 0, and all of this will go to 0. So that allows me to solve for b. So let's check this out. So you have 1 square, that's 1 on the left side. On the right side, so the first term, all of this goes to 0. So the b term survive. You have b times 1 plus 1, that's 2. And then 1 squared plus 1, that's also 2. And this cancels. That goes to 0. This gives you b is equal to 1/4. All right, so that's good. Now let's pick another convenient value. I'm going to go with -1. So if I pick x equal -1, this survives, but this will go to 0. This will go to 0. So that allows me to solve for a. So on the left side, you have -1 squared, that's 1. And then you have a times -1 minus 1, that's -2. -1 squared plus 1, that's 2. And of course, these are 0. Verify them on your own. I can see that they're 0, so I hope you can see that too. So this allows us to solve for a. A is -1/4. Right, so we got two constants down. Now let's see what can we do with c and d. I'm going to pick x equals 0. If I pick x equals 0, well, a will survive. B term will also survive. For this one, c will go to 0, but d will survive. So we can solve for d. So that's great. So let's go ahead and plug in 0 for x. On the left side, you have 0. On the right side, so when you plug in 0, this is a times 0 minus 1, that's -1. 0 plus 1, that's 1. For this one, when you plug in x equals 0, you have b times 0 plus 1, that's 1. 0 squared plus 1, that's 1. And then for this one, c disappears, so you have just d times, so this is 1. And then -1 minus 1, that's going to give you, so 0 minus 1, That's going to give you -1. All right, so let's plug in a and b since we know those coefficients. So this is 0 equals, a is -1/4 times -1, that's +1/4, plus b is 1/4 times 1, that's 1/4, minus d. And then if you solve this, you will get d is equal to 1/2. Wonderful. Now we got one more constant to solve, which is c. Now you can pick any x value really to solve for c. I'm going to go ahead and pick x equals 2. Something easy, convenient. Plug in x equal 2. So you have on the left side a 2 squared, that's 4. On the right side, you have a is -1/4. And then 2 minus, so I'm working on this one. 2 minus 1, that's 1. 2 squared plus 1, that's 5. And then for the second term, so this one, b is 1/4. And then 2 plus 1, that's 3. And then 2 squared plus 1, that's 5. And the last one, plugging in 2 here, you get 2c plus d. D is 1/2. And then 2 plus 1, that's 3. And then 2 minus 1, that's 1. All right, so let's clear this up. So you have 4 is equal to -5/4 plus 15/4. And then here, for the last term, I get plus 2c, 6c, actually, if you distribute, and 3/2. And now I can combine further. This is 4 is equal to 10/4 plus 6c plus 3/2. Now let's go ahead and multiply both sides by 4 to get rid of the fraction. So you have 16 is equal to 10 plus 6c plus 6. So you have 16 is equal to 16 plus 6c, and you can see that c is equal to 0. All right, so that's good. We have our coefficients. Now let's plug them in. So I'm going to go ahead and copy this to the bottom and work it out with these values for a, b, c, and d. The integration is often very simple. Difficulty is finding these coefficients. So we have a is equal to -1/4, b is 1/4, d is 1/2. So this is a is -1/4, and then b is 1/4. C is 0, so this will disappear, and D is 1/2, so this is just 1/2. All right, so now let's integrate these. I'll separate it into 3 pieces. This is -1/4 integral of x plus 1 plus 1/4 integral of 1/x minus 1. And the last one, pull out the 1/2. You have the integral of 1/x squared plus 1 dx. Now 1/x plus 1, that's ln of x plus 1. This is -1/4 ln of x plus 1 in absolute value. Hold on to the integration constant. 1/4 another ln of x minus 1 plus 1/2. Now this is arctangent or tangent inverse. 1/2 of tangent inverse of x plus c. So that's one answer. Now, if you want to be very fancy with the laws of logarithms, you can rewrite this, or you can say this is 1/4 ln of, so it's going to be this one over that one, because that's where the subtraction is. Will be x minus 1/x plus 1 plus 1/2 tangent inverse of x plus c. So that's another way to write the same answer. All right, so I hope this helped. See you next time.